Hi guys. Today we're starting chapter 7. Chapter 7 is all about logs, logarithmic problems, equations, expressions. Um, Due to spring break, we will be splitting this chapter into two parts. So we'll do half of it before spring break, and we'll take a test before spring break, and then we'll do the other half after spring break. And those two halves together will make the one whole 100-point chapter 7 test. So 50 points on the Friday before or Thursday, depending on what class you're in, and then 50 points after spring break. Because of this, also, we had to rearrange the chapter a little bit so that it would make sense to you, and we needed to find a good natural breaking point. So we are starting in chapter 7, section 5. And today we're going to be focusing just on the first one, exponential equations. So that would be an equation where your variable x is in the exponent. Now, because we're dealing with exponents today, you might want to take out the secret compartments that we made during class. And because that has all of our rules about exponents, and you definitely need to know those rules. We made those secret compartments just last chapter. All right, so let's get started. So here is our first example. And so this example says 27 to the power of 3x equals 81. And then we want to figure out, what does x equal? 27 to what power becomes an 81? Now, in this chapter, it's going to be especially important that you are writing your numbers in the correct format. So your exponents need to be smaller and above. If we start writing them a little bit too big, we're going to be solving completely different problems, and we're definitely not going to get the right answer. For all of today's problems, we're going to get what's called a common base. Now, if you remember from last chapter, the base is the big number, right? And then the exponent is the little number. And so when I say we're going to get a common base, that means that we're going to make the big numbers be both the same big number. And in this scenario, 27 and 81 can both be written as a base of 3. When you're trying to write these as a common base, we're sticking with just exponents. So this chapter is going to be all about exponents. In fact, when we learn about logs later this week, we're going to learn that logs are an inverse of an exponent. It's how to get rid of an exponent. So this chapter just keeps diving into exponential problems. All right, so maybe you didn't know this, and we'll talk about this a little bit more in the live session, and I'll show you where you can study your common exponents. But 3 to the third is 27, and 3 to the fourth is 81. So since 27 is equivalent to 3 to the third, anywhere I see a 27, I can remove the 27 and in its place put a 3 to the third. Same thing with 81. Since 81 is equal to 3 to the fourth, anywhere I see an 81, I can replace it with a 3 to the fourth. So in this problem, I will be removing the 27 and the 81 and putting in 3 to a power. Okay, so the 27 is gone, and now it is a 3 to the third. The 27 already had an exponent on it, and so that exponent still needs to be there. So that 3x is still there. And then the 81 got replaced with the 3 to the fourth, and 81 did not have an exponent, so 3 to the fourth is fine on its own. Looking at our rules about exponents, a power to a power, 3 to the third to the 3x, those two exponents get multiplied together. So I'm going to do the small 3 times the small 3x. I'm not going to do anything with the big number 3. All right. Now, logically, if I have 3 to a power equals 3 to another power, those powers should be the same, right? 3 to a power, 3 to a power, they have to be the same power. So once you get your common base, once the big numbers are the same big number, you can actually cancel those out. And then you can create a new equation using just the exponents. So completely separately, I'm going to take just the exponents, the 9x and the 4, set those equal to each other. Look, I even wrote it in a different color, right? So now we're dealing with just the exponents. And I've discovered that my answer is 4 over 9. 27 to the power of 3 times 4 over 9 should equal 81. And you can always try that in your calculator if you want to. Now, if you are going to try it in your calculator, parentheses are your best friend. You have to make sure that you enclose the entire exponent in parentheses. Otherwise, the calculator won't know what you want it to do. Let's try another one. Okay. So here I have 8 to the power of x equals 1/4. Now, again, this is 8 to a power. It's not 8 times something. Okay, so we need to find a common base. So we need to think of a number that when we raise it to a power can turn into a 4 and can also turn into an 8. Now, that number is not 4. 4 squared is 16. So that's not going to work for us. But maybe you noticed when we were doing all of our radicals and everything, we kept getting like the cube root of 8. Or maybe you kept factor treeing your 8s, and your 8 turns into 3 number 2s, or 2 to the third. So my common base for this problem is going to be the number 2. 2 to the third is 8, so I can replace the 8 with the 2 to the third. And 2 squared is 4, so I can replace the 4 with a 2 squared. Just like on our previous problem, 2 to the third to the x, I'm going to multiply the 3 and the x together. Now, at this point in time, I don't have a common base because on the left-hand side, it's the number 2, but on the right-hand side, it's a 1/2. So I need the right-hand side to also be a number 2. I need to take the reciprocal of it. So this is kind of working backwards, and you can look this up in your secret compartments. So we don't want the fraction. We actually want it to be a whole number. And the whole number that it was before it became a fraction was a whole number with a negative exponent. So we learned last chapter that negative exponents will take a base and drop it below a fraction bar. So now we're doing the opposite. We've got a base below a fraction bar. I don't want it there. I want it back up top. So let's make the exponent negative. To change a fraction into a whole number, give it a negative exponent. Well, now I've got my common base. I've got a 2 on both sides. I can cancel those out. I can set my exponents equal to each other. And my final answer for this one is -2/3. Let's have you guys try some on your own before we do our homework, just to make sure you're getting these right. So here are 4 for you to try on your own. Some of them a little bit easier, some of them a little bit more difficult. So do your best, pause the video, and then when you're ready, restart the video and check and see how you did. All right, so we're going to check our answers 2 at a time. So here are the answers to numbers 1 and 2. So on number 1, the common base is the number 5. So 25 can be replaced with a 5 squared, and 125 can be replaced with a 5 to the third. Notice that I made it a -3 because it was a fraction. This is very similar to the one that we had just done. For number 2, both of these can be with a common base of 6. Now, the left side already has a 6. We just need to replace the 36 with a 6 squared. When you have adding and subtracting in your exponents, make sure to distribute. So the 2 from the 6 squared is going to distribute to the x and the -1. So 2x minus 2, and then solve from there. All right, let's check 3 and 4. So on number 3, the common base can be the number 8. 8 squared is 64. You also could have used a common base of 2, but that gets the number gets really, really big, but it also would have worked. Now in this one, the 2 again is going to distribute to the x plus 1, but this 8 on the other side, it doesn't have an exponent. So if something does not have an exponent, it actually does have an exponent, and the exponent is the number 1. So on the left-hand side, go ahead and put an exponent of the number 1 there. And then that will make it so that you can solve this problem. It's not a 0. Remember, an exponent of 0 would mean that there was no base at all. So put an exponent of 1 up there. And then finally, for the last one, we did this common base earlier today. The common base is 3. So 9 becomes 3 squared, And then if I want it to be a whole number, I make it a -2 instead of a +2. And then 27 is 3 to the third. Here again, you'll have to do some distributing. All right, guys, just one video for today. So this is the end, and I will see you all tomorrow.